Okay, this is the lecture over 1.5. In this lecture, we're going to be talking about systems of linear equations. So there are three types of solutions. Yikes! Okay, one is a unique solution, and this is when you get solutions that are x equals a number and y equals a number, and you're going to write these as x comma y. Okay, you have infinitely many solutions, and we'll have some of these, and I'll write those, you write those differently. And then you have no solution, and you'll write those as no solution. Okay, and those are your three types of solutions. Now, when we have systems of equations, we have four ways to solve them. We have elimination, substitution, graphing, which is done on the calculator, and I'll tell you what I expect when you solve it that way. And we have matrices, which is chapter 3. Now, elimination and matrices are very similar. Okay? And so you'll see that. Now, the first one we're going to do is by substitution. And this is the most common one, and it's the one that most people do. And what I have found is that people are told that you always use this one, that it doesn't matter, you always use substitution. And that's not the case. I tend to always use elimination, but it's just whatever you're most comfortable with. Unless I tell you a specific method, I don't care. When we get to chapter 3, I'm always going to want you to use matrices. But other than that, I don't care. So, when you solve by substitution, what that means is that you're solving for one variable, putting it into the other equation, and solving for the other variable. So, we're going to first solve equation 1. So, I've labeled the equations 1 and 2. Let me go here and see. I'm going to change the color of my ink real quick. Just so, because I'm writing, my background is in blue. Let me see if I change it, if it'll help. We're going to solve the first equation for y, and then put that into equation 2. So if I solve the first equation for y, I'm going to move the 2x to the other side. And so actually what I did is I didn't move the 2x to the other side, is I moved the y over here and the 2 over here. So I added y to both sides and subtracted 2 from both sides. Same difference, just a different way, but it gets me the same answer. Then I put that equation into the second equation. If I had gone about it the other way, I would have had minus y equals minus 2x plus 2, and then I would have had y equals 2x minus 2. So it's just a different middle step. But it doesn't matter. Either way, I get to the same answer. Now, when I go about, after I substitute it in, I'm going to distribute the 4. Then I combine alike terms, and I move the 8 to the other side. Then I divide both sides by 11. Okay? Then I'm going to put the 14 into the y equals 2x minus 2 for x. Then I multiply the 14 times the 2, because remember this is 2 over 1. And then from here to here, I'm getting an LCD of 11, right? Because this is 2 times 11 over 11 to get that least common denominator, which gives me 22 over 11, right? Then when I subtract, I get 6 over 11. And remember, this is the ordered pair x comma y. That's my solution. Okay? Now, for elimination, what you're going to do is you want to eliminate one variable. So I could either eliminate x or I could eliminate y. So what I'm going to do here is I'm going to eliminate y. So I'm eliminating y, not x. So I'm going to multiply the first equation by 2 and the second equation by 3. Okay, when I do that, that gets me this set of equations. And so then when I add them, I get x equals 5. Now, when I say multiply each equation, notice that I multiply both sides, not just one side, both sides. Ook. All right. Then once I find x equals 5, I put it into one of the equations. Now, what I did is here's using once, so I did it twice so I could show you that it doesn't matter which one you get. Okay, so this is using equation 1, and this is using equation 2. So this is 2, and this is 1. And both times you get 4. All right, I just did it using both equations so that you know that you get the same answer. Okay, now for the next example, what I'm going to do is I'm going to show it to you on a calculator, and then I'm going to show you the algebra. So first I'm going to switch over to my calculator. So here's my calculator app, and I have already entered y equals x, my two functions, into my calculator, and I'm going to graph them. Okay? Now, with this calculator app on my iPad, in order to find the intersection point, if I go right here and I hit calc and I want to find the value, what I want to find is I want to find where they intersect. Then I move my pen. I have a pen, a writing pen. I want to find the intersection point, and it tells me. It says I intersect. Isect. Now, for the TI-83s or the TI-84s, what you're going to do is you're going to calculate. And so let me hit done. And up above these functions, there'll be one of these that'll say calc. Let me go back into graph. Done. Up above these where it says stat plot window format table, one of them will say calc. And if you hit second in that button in the graph mode, then what it does is it'll allow you to, and then it'll have intersect or insect. And you'll hit a place here on one curve, a place here on one curve, and then a guess. And then it'll come up with what that exact value is. Okay? And then if you hit frac, it will tell you what the actual values are, not the frac. Now, 0.66666 is 2/3. And I forget what 4.888. I have it on my sheet of paper. So now I'm going to go back into Adobe. And I'm going to show you how to do it algebraically. This, again, is an algebra class. So it's all going to be about how to do the algebra. Okay? Now, doing the calculator is important, and it's a great way to check yourself, but you still need to know the algebra. All right? So what you're going to do the algebra is you're going to want to set equation 1 equal to equation 2, and then solve. So first thing, I do is I'm going to multiply both sides by the LCD. So the least common denominator for these two fractions is 4. Okay? So if I multiply both sides by 4, then that will get rid of these fractions. Okay? Now notice what I'm doing is I'm going to distribute this 4 to every term. Okay? I'm going to scroll down. And when I did that, that multiplies it out and multiplies it through. So then I get 32 when all the fractions are gone. Scroll up just a little bit. So I get 32, then 4 times 3 halves, then 4 times 3/4 minus 12. Then I get 32 minus 6x equals 3x minus 12. So now I have a linear function. Well, that's a lot easier to solve. So I'm going to add 12, so I get 44, and I'm going to add 6, so I'm going to move this over here and the 6 over here. So I have 44 equals 9. Divide both sides by 9, so I have x equals 44/9. All right? So then I put that into either one of the y equations. And I just picked the one with the 3 halves. And the reason I picked the 3 halves is that I can make the 3 and the half go bye-bye. Okay? Now you could have picked the 3/4 and the 3/4 would have gone away, but I just picked the 3 halves. All right, so now what I did here is I said 2 goes into 44 and leaves 22, and 3 goes into 3 to 9 and leaves a 3. All right, so what that leaves me is this whole thing right here becomes 8 minus 22/3. So then to the next line, I get 8 as a fraction, which is 24/3. And so y equals 2/3. So now I have the point 44/9 and 2/3. And that is my intersection point as a fraction. All right, now let's talk about the word problem, because that's where we're worried about. All right, so if we read the question, this should actually be a 30. Okay, found that out today when I taught this lecture. Okay, write a concert promoter needs to make this much money from the sale of this many tickets. The promoter charges $30 per ticket and $50 for others. Let X represent the number of $30 tickets and Y represent the $50 tickets. So X equals $30 tickets and Y equals $50 tickets. All right. Then write an equation that is the sum of the tickets that equals 1,740. So there's my first one. Write a formula for how much money is received from the sale of $30. Well, that's simply this. On a test, this question would not be asked. Write a formula for how much money is received from the sale of $50 tickets. 50 times X. Again, on a test, that would not be asked. Those two are just simply expressions to help you write part D. Write an equation that states the total amount received from the sale of this $62,200. Well, most students can go just to that equation. Well, if I want to write an equation that states the total amount received from the sale, well, that's going to be the number of $30 tickets plus the number of $50 tickets. Right? Okay. So then part E is solve that system. Now, like I said, most students want to solve this by substitution. So y equals 7 1940 minus x, put it into the second one. Distribute. Okay? Then you get that. Then you have 20 minus this, so x is 1240. 1240 plus y equals this, so y is 500. So you must sell 1,240 tickets at $30 and 500 tickets at $50 to earn $62,200. Okay? One safe investment pays 10% per year and a risky investment pays 18% per year. A woman who has $142,300 would like to invest this amount and earn $19,430 per year from the investments. Okay, so I'm just letting you know that time, T, is 1. She would like to invest, how much would she invest at each rate? So I have two investments. So I'm going to let X be the amount at 10% and Y be the amount at 18%. Then X plus Y equals 142,300 and point X plus 0.18Y equals 19,430. So what you're going to do, I'm doing this by elimination because I want to show you that not everything has to be done by substitution. So I'm going to multiply equation number 1 by negative 0.1. When I do this, the x's become 0. Okay? So I get 0.08y equals 5,200. So then y equals 65,000. So now I have that x plus 65,000 equals 142,300. So then x is 77,300. Now, here's one of the things I've told the live class, and I'm going to say this to y'all, to the online class. Every time you write a complete sentence, that's plus 1 bonus. Okay? For the sentence. So make sure you're writing those sentences. All right? If you have any questions, please email me.